Yes, another coding video. A lot of you seem to enjoy the previous code video, so I decided to make another. Or rather, I need one for marks, but who cares about that? So what are we explaining today? Well, in the last one, we looked at the beauty of arrays and how absolutely overpowered they are. That code was less than 100 lines long, so I was able to remake it live and explain it slowly and more in depth as we coded it. This code, however, is almost 500 lines. I mean, I'm not complaining, that's not even that large in the grand scheme of things. It's just that I won't be able to recode it live this time. In the previous video, we made code that made some beautiful 3D houses, so let's see what the project is this time. Oh, anything we want. Okay, let's make NumBot. Now you may be thinking, what the heck is NumBot? Well, here's the short answer. NumBot is a program that guesses what number the user drew from 0 to 9. Yeah, that's it. So how do we make it? Well, first we need an area for the user to draw on, and to make it simple, it will just be a 5x5 button panel where you can toggle the buttons on and off. Okay, so how do we draw the buttons? Well, we can draw them using arrays, and we can make an array that is 3 spaces long, one for the X position, one for the Y position, and one for the state of the button, which is on and off. And the drawing command is just this for loop telling the array to add a certain amount to the X position until it reaches the end of a row. When that happens, it will update the Y position and start a new row. This will repeat until we have 25 buttons in a 5x5 grid. Okay, now we have 25 buttons, and they send a signal to nowhere. Now comes what I thought was the hardest part, but ended up being extremely easy: the logic. First, we have to detect lines, which in this case are 3 buttons turned on next to each other. Using this definition, we can make a total of 15 horizontal lines and 15 vertical lines. Second, we need to have a function that takes 3 certain points and takes that result and stores it in a space in an array. So we gotta make 2 more arrays, one for storing horizontal lines and another for storing vertical lines. Both of these arrays have 15 spaces to store all the possible lines. This function can also turn on one of 3 flags: top row, horizontal detect, or vertical detect. Top row turns on if there is a horizontal line on the top row of the grid, and the rest are pretty self-explanatory. Okay, so now we have a way to detect what type of line has been made and where it is on the grid. Now we have to move up a layer and start detecting angles. Now there are 2 types of angle detections that NumBot uses, which I like to call basic angle detection and core angle detection. Now if you remember the flags we said earlier, horizontal and vertical detect, we can easily make an angle detection with an AND gate using these 2 flags, and that's basic angle detection. Core angle detection is a bit harder though, but first we need to know what core angles are. To put it simply, core angles are angles whose horizontal line goes through the middle row. These are the angles that NumBot uses to estimate what number has been drawn, like 2, 4, 5, 6, or whatever. There are 4 ways to orientate the core angles, so we name them core angles 1, 2, 3, and 4. You know what the next step is? Another function. So if we look at the grid for a second, you can see that there are only 3 spots that each core angle can be in. So we need an if statement with 2 ors that makes 3 different spaces. Another shortcut we can take is the fact that every core angle uses the same horizontal lines, so we only need parameters for the vertical lines, and then we make the function return a value so it can be assigned to the core angle variables, and boom, here's the function. Finally, we have number detection, which is actually pretty simple. Each number detection code is very similar and easily customizable to make one for every single digit. So for this part, I'll explain the code in the order of the digit with the least parts to the digit with the most parts. Starting with number 1, we only want it to turn on when we start the program by clicking the display. So at the beginning, we put if start equals 1. The next part is the criteria of the number showing up, which in the case for 1 is very easy since we can reuse vertical detect. And the final part of the criteria is to override 1 if a number with more parts has been detected. So in the last part, all the other number detection variables have to be set to 0. The next number is 7, so first we do start equals 1, and then the criteria for 7 is also pretty easy. We just use our 1 horizontal line and 1 vertical line, which sounds familiar because that is literally our basic angle detection. Then the last part is the override, and we fill it with every single number except 1 because it is below 7 in the priority. Now we have 0, which introduces 2 new variables, hline count and vline count, which are just 2 variables that count how many horizontal and vertical lines have been made. So this time the criteria is 7 detect, which is just the basic angle detection, plus 1 other horizontal and 1 other vertical line. And lastly, we put the override, obviously not putting the numbers below the priority. So you can start to see the pattern here. So for this next part, I'll make the explanation quicker and only name the criteria and the numbers that override it. Next up is 2, which requires core angles 2 and 3 and gets overridden by 4, 6, 9, and 8. 3 comes next with the criteria being core angles 2 and 4 and gets overridden by the same numbers as 2. Now we have 5, which is activated with core angles 1 and 4, also overridden by the same numbers. 4 has a criteria of core angles 1, 2, and 4 and gets overridden by 9 and 8. 6 is core angles 1, 3, and 4, overridden by the same numbers as 4. Next we have 9, which has the criteria of core angles 1, 2, and 4, and the top row flag we mentioned earlier. 8 is its only override. And finally we have 8, which is all 4 core angles and has no override because it is the digit with the most parts. And that's it! That's basically the main bulk of NumBot explained. There's a couple more features that I added, such as game states for the menu screen, and some little mouse hover graphics that turn the squares blue, but those features are too small to warrant an entire explanation. So now this is the part where I talk about how well I followed my little coding plan, which was almost too well. I got all my level 3 features and the majority of my level 4 features within the first week, which gave me an entire week to optimize code and add new features. And I think this project deserves a level 4, which, if I ever make this public, it's like the highest grade in terms of numbering. I was able to get all the features I wanted, plus I was able to get that little hover graphics thing last minute. And in terms of the takeaway, last time I ranted on how arrays were the best thing ever, but in this project, functions really carried. There's a lot of functions used throughout this entire program because there's a lot of repeating code, and that means there is a lot of room to put functions to make the code a lot smaller than it had to be. So other than that, that is NumBot inside of Java. If you don't already know, NumBot was originally a Minecraft Redstone project, and I just put it into Java because why not? Even added some extra features. So yeah, there's not really much else to say anymore.